Okay, welcome back from the coffee break, which was sponsored by Frequentis. I'd also like to thank again all our sponsors for their support to the EUROCAE Symposium. The gold sponsors Airbus, Indra, ENAIRE. Silver sponsor Collins, bronze sponsors Frequentis, Anzen, Skyguide, and Honeywell. And also our partner, the European Union, European Commission. So our next speaker is actually from our partner in the European Commission, Directorate General, Defence Industry and Space, Ignacio Alcantarilla Mendina, who I know as INECI. So INECI's team supervises the adoption of Galileo and EGNOS in aviation. This flash talk is on supporting ambitious EU space programs. EUROCAE is developing the standards needed to support the implementation of these ambitious programs in cooperation with DG DEFIS. So a warm welcome for INECI.
Thank you very much. Thank you, Mark. Thank you, EUROCAE, for inviting DG DEFIS to this flash talk. I will be presenting some of the initiatives of the EU Space Program, EU Space Services in support to aviation. So it's a very simple and quick talk. I will introduce to you first what is the EU Space Program. We have 2 slides on PNT, Position, Navigation and Timing, which is where I am working on, but we are also going to cover a little the other components. So the EU Space Program, as you may know, has different components which deliver services. Some of them support aviation services. We have an Earth observation component, which is Copernicus, whose services are mainly related to land applications, but there is one service in which, indeed, we are not rather supporting aviation, but we could benefit from aviation to develop Copernicus service. This is the atmospheric monitoring service. And indeed, we are working with DG Move, which is the other Directorate General in the European Commission dealing with transport and in particular also with aviation, on trying to understand whether we could make use of the sensors that are on board aircraft to improve the services that this Copernicus atmospheric monitoring service could deliver in the future. So in this case, Copernicus' involvement in the aviation community is rather that we would like to use sensors that are being already deployed in the aviation ecosystem. Okay? But apart from Copernicus and apart from Galileo and EGNOS, which are the 2 components dealing with position, navigation, and timing, we have other components in the US Space Program. We have, as you may know, GovSatcom, SST, which are working on, notably SST, on developing what we call an EU Space Act. This EU Space Act will be a piece of law that will apply to providers of space services, but it may have also an impact on aviation. And this EU Space Act will try to generate a single market of EU space services in the EU. Today, we have already 12 member states delivering or having rules and regulations on space. We have more member states that are developing their own, and we want to integrate that into just one piece of the legislative rules that could apply to all the EU member states and stakeholders. There are several pillars that will focus this piece of law, which are safety, resilience, and environment. And indeed, we want to make these rules as smooth as possible for the already existing operators. And we also want to support industry with specific measures so that the adoption of these measures is as smooth as possible. Okay? This is for the components SST, so in a way, tracking and monitoring space assets. There is another component which you may have heard of, which is IRIS², okay, which is the governmental communication services that we are going to deliver through a constellation of typically LEO satellite, low Earth orbit satellites. Okay? It is still early to say whether there will be these communication services, which are basically for governmental applications, but also commercial applications. Some of those will be applied for aviation. My colleagues in DG DEFIS are discussing with the colleagues in DG Move to understand indeed which of these services, communication, for instance, could be applied also to the aviation ecosystem, and what are the requirements that they will need to be compliant with, like certification and so on, okay? So then we have another component on top of the Copernicus one, on the SST one, which is IRIS squared. It's still early to say which kind of services can serve aviation. And then we have the Galileo and EGNOS components, which are two, but in principle, it's the same, is position, navigation, and timing. And we have there how we are delivering services from space that indeed can be used for PNT or CNS, the navigation and surveillance part. Okay? So I'm going to focus the talk on those two components. And for you to know, we are going into the maybe the major challenge that we are facing today in aviation, coming from the space-based services, which is the radio frequency interference. We have discussed already in previous sessions. Okay, I'm going to present to you very quickly in this slide what we are doing from the DEFIS point of view. Okay, you will see there that we are structured in MFFs, so multi-financial frameworks. This is very important for us because there are a number of activities that we can only undertake if we have the mandate in a legislative piece of law and the budget and resources to implement them. This is why we are working to have that mandate and resources for the next MFF, which starts in 2028. While there are other activities that we are already implementing them and we don't need this additional mandate resources perspective. So if we go to the different activities we are doing, and I will start with the authentication services. So we can authenticate the services so that at the end, the spoofing threat, not so much the jamming threat that may come through another mitigation means, but the spoofing threat is mitigated. And we are indeed implementing different services, OSNMA, SAS, authentication in the second generation. I will go a little more in detail in the next slide. Okay, this is something that we are doing independently on the MFF. We are also monitoring, as some of you stakeholders are, RFI interference based on open data, and the clear example is ADS-B data. Okay, there are several websites and applications that do so, and we intend to do so. But we are also investigating the possibility to purchase commercial data from LEO satellite providers that today they sell radio frequency interference monitoring and location of sources from space. Today we have non-EU companies, unfortunately. I think the most prominent one is EUROCAE. But in the future, we hope to have, in 1-2 years, EU-based companies that deliver this kind of services. So with this kind of services, you can get a global view or a regional continental view in a time frame which is in the order of 30-45 minutes, which is very powerful to detect whether there is interference in a certain area. Okay? This is then something we are now considering purchasing this data, and there was a market consultation that was open, and we are analyzing the results. But not only we want to rely on open data or commercial-based data, we would like to have the EU capacity to monitor and localize RFI interference sources. For that, we are preparing that with research and development projects in this MFF. We have R&D on space and ground-based capacity, and we have also EDF, so European Defence Fund projects, where indeed the member states are also analyzing how to monitor the RFI spectrum in the GNSS bands, but not only. If everything goes fine, and in the next multi-financial framework regulation, we have the task to implement an RFI monitoring service. From 2028, we will develop an EU-owned RFI monitoring service, okay, which will come on top of open service or commercial initiatives. Of course, we are open to have partnerships with member states, with stakeholders, to monitor better the RFI monitoring. And at the end of the day, what really will matter here, and maybe it's not so obvious from the very beginning, is the last line, is the governance that we will put into this potential EU GNSS RFI monitoring service. Today, the EU doesn't have a mandate to monitor the RFI spectrum, sorry, the radio frequency spectrum, more than supporting member states when they ask us to really help them to monitor RFI. But the mandate is at member states level. So we need to figure out and to get the mandate from member states, and the right way to do it is to have a regulation at the level of member states, so Council and European Parliament, and this is the next MFF regulation. So we really need to figure out and agree with member states what's the governance of this service and what is the things that the EU, the Commission in this case, in the next MFF could do. Okay, you probably know that RFI activities, they are impacting very much aviation, but they are linked to military activities, and not only from non-EU countries, also from EU countries. So some EU countries are very sensitive to the fact that we monitor RFI, and this is what we need to sort out, in which considerations and with which constraints we can monitor such activities, okay? So this is why the discussion on governance, it's ongoing. It is very important. It's ongoing with the member states in our committee meetings. So in DG DEFIS, we have several EU Space Program committee meetings, and then we discuss with the representatives of the member states there. Then the next MFF will have a proposal from the Commission, as it is always the case, that we will issue June, July this year, and then it will go into the cycle of Council and European Parliament, where they will make amendments, they will request to include or remove activities, and there, at the end of the day, before the end of 2027, we should have an European Parliament and Council adopted next MFF regulation. We hope to have the governance solved and the mandate to do the monitoring of RFI in this piece of law. And then if everything goes according to plan, in the next MFF, we will not only deploy the space and ground-based capacity to monitor RFI, but we will also make the operations at the service provision, and we will also, of course, support these activities with standard guidelines and regulations for dedicated market segments, sectors, if need be. Okay? So a lot of activities going on. We have a limited capacity in this MFF with a limited mandate and resources that were anticipated in 2021 when the current MFF regulation was adopted, but we are working on having the full capacity and mandate for the next MFF and develop an EU-owned RFI monitoring service that will have ground elements, but we also have space-based elements, or notably LEO components, which will indeed allow a monitoring of regional RFI much better than just having ADS-B or regional on-ground sensors. Okay, so this is the roadmap, the hint on RFI that we are working from the DEFIS side. We are coordinating with MOVE, with DG Connect, of course. At the end, the proposal for the next MFF regulation from the Commission will be a Commission proposal, will not be just a DG proposal, but in terms of working methods, we are pushing from DEFIS this RFI monitoring service. Then the second slide, which is important because the first line that you saw in the previous slide was improving the resilience of the EU space-based services, so Galileo and EGNOS in this case, is a little declinated in this slide. So you know that we don't only need to deliver services which are more resilient, Galileo, OSNMA, Open Service Navigation Message Authentication. It's already there. It's going to be declared in a couple of months, but the signal in space, the cryptographic material, everything is really there, and receivers are implementing this service. It is one part of the equation. The second part of the equation is that in regulated segments, like aviation, this is fully adopted in these standards, okay? And we are working with EUROCAE intensively to include in the MOPS ED 259 revision B that we expect to have published early 2027, a MOPS version that will include not only DFMC, so dual frequency multi-constellation, GPS and Galileo, but also the Galileo SNMA. So that means that part of the spoofing threat, which is going into the navigation message part of the Galileo signal and change it, will be impossible because it will be signed, and then the receiver will only certify those navigation messages that have been indeed generated by Galileo with a private key, and the receiver will have a public key. Okay, so this is part of the threat, which is changing the navigation message, will be covered with this standard. This is a very important threat. You may think, well, it is very difficult to change the bits in the navigation message and then spoof an airplane and make it believe it's somewhere else. It happens. It happens very often. Maybe you have heard of cases where airplanes came from the east, from Russia. They were spoofed in the east flank, as my colleague said at the beginning, but they were impacted not only when they were in the spoofing area, but much later, even over Germany, over France, and even in one case when landing in New York. And this is possible because the navigation message that it's uploaded in the receiver, it is spoofed. And then the receiver stores several navigation messages. When you spoof a navigation message that it's in the future, only when the future will come, 4, 6, 8 hours, then you will see a wrong navigation message, and then you will be way out of your real position. So part of the spoofing threat we are seeing today will be covered by OSNMA. But we are not only going to go to revision B, but that, by the way, already includes onboard receiver resilient measures. There will be checks between code and phase, simple checks that will be able also to detect interference. And we have indeed prototypes that show that they work very well, these checks. So this revision B is the first step. We hope to have certified receivers already after the ATSO will be developed by EASA in 2027-8, which will be embarked in aircrafts. But we are also going to include the SBAS authentication part. You may know that today for certain applications like precision approach, you cannot just use GPS. You will not only be using GPS and Galileo in the future. You need an augmentation system. So in Europe, we have EGNOS, which is the SBAS augmentation system that delivers a new signal with the augmentation information. That augmentation information will be also authenticated. And this will come in a version of the MOPS, which is revision C, which will be published by mid-2029. So we hope then that by mid-2029, we will be able to cover the spoofing threat of SBAS and the spoofing threat of Galileo SNMA. By the way, one thing that's maybe important is Galileo SNMA will not only authenticate the Galileo navigation message, will also authenticate the GPS navigation message, okay? Because there is the possibility, we have a space enough in the navigation signals to include some bits that indeed authenticate the GPS message. So at the end, you may have a fully fledged solution, GPS, Galileo, EGNOS, by the end of the decade. Okay? So this is part of the threat. The second part of the threat is the measurement itself. Not the navigation message, but how you get the distance from your receiver to the satellite. Okay? This is coming very soon in one service that we call SAS, Signal Authentication Services. Unfortunately, this is in a frequency which is not aviation protected. It is an E6, okay? It's not E1 or L1, L5. So in the first generation, we only had the room to put it in this signal. In the second generation, and this is going to come in 2026, in the second generation of Galileo, which is coming by the end of the decade, we will include the authentication of the measurements, the zero range, also in E1 and E5. But the but is that the satellites will start being launching by the end of this decade, and then you will only have a full constellation of Galileo in 15 years, because this is typically the lifetime of satellites, okay? So then, at the end of the day, we are working to deliver improved and more resilient GNSS services from the EU components, Galileo and EGNOS, even including the GPS one, when possible, for aviation and for other domains. And then my last message is that you have a say on which services we could deliver in the next MFF. There is a public consultation ongoing for the next MFF, okay? And then when we will propose in June, July, the Commission proposal for the next MFF regulation, it will go to Council and Parliament. So member states will tell us, no, I would like that you deliver this service, or I would like that this is a priority with respect to this other service. So it is you, member states, and then all the stakeholders that contribute to its member states that will tell us what we need to do from 2028 onwards, with a piece of law and a budget and resources necessary to do it. So at the end of the day, we are only implementing what you tell us every 7 years. So it's now the opportunity for you either to contribute to the public consultation or to go through your member states and let us know which kind of services are required for aviation. Voila. So I'm sorry to have gone speed of light. I hope everything was clear. Anna, I think I am on time. So thank you for your time.
That's it.
All right, thank you, ENAIRE, for this wonderful video. Hi everyone, buenos dias, bonjour. My name is Bertrand Riveil. I am the Technical Program Manager coordinating drones and eVTOL topics at EUROCAE. It's a pleasure to be with you today. This is my first symposium. I'm very happy to be with you. Our next panel will talk about innovative aerial services. The discussion will center on concept development, new technology implementation, and aerial operations. We will see how 4 different companies carry those subjects and advance forward. They will address key points such as the use of vertiport for VTOL, safety practices for operations, and the use of automation for flights. Also, the panel will explore the key enablers currently missing inside the ecosystem, crucial for a smooth way forward. We hope to bring you a comprehensive overview of the transformative impact of innovative aerial mobility on aviation and its future trajectory. Please, welcome our speakers. Daniel Molina from Bluenest. Fabien Bouyssou from CRISALION. Javier Romillo from Anzen. And Diego Fernández from Wing. And finally, last but not least, our moderator from ENAIRE, Daniel García-Monteavaro.
Thank you. Well, you have the Slido if you want to ask questions later. And well, as an introduction, good afternoon, everyone, and welcome to this insightful session. I think it will be quite interesting. We are going to talk about the innovative air services operations from concept to implementation. Today, our goal is to dive into the practicalities of these innovative solutions, moving beyond exciting concepts and exploring the crucial steps required to bring these revolutionary technologies to life. We stand at a pivotal moment where the theoretical potential of electrical vertical takeoff and landing vehicles and advanced drone applications is transitioning into tangible operational frameworks. This session will focus on the journey from initial ideas and technological breakthroughs to the real-world deployment and management of innovative air mobility systems. And for that, we count, of course, on a panel of leading experts to talk about this fantastic topic. They're good examples of who are actually building the future of innovative air services operations. And first, we will have a brief introductions of each of us about different topics of this concept. We are going to talk about vertiports, eVTOLs, delivery with drones. I will start my brief presentation of ENAIRE with an innovative air services perspective. Of course, ENAIRE was introduced yesterday by our general director, but we are going to look how we are dealing in this sector. I remember, because we are in a EUROCAE Symposium, my first contact with EUROCAE when I started as engineer in CNS systems, in NAVATES, BORs, DMEs. We are talking about the ED57, ED52, that are quite old standards. And of course, the ED109 with the software assessment level. Also, I had to work with it in ENAIRE when we started with that in the CNS systems. And I also participate in the kickoff meeting of the working group 107 related to DME and DME air nav navigations. Well, ENAIRE, it's a public entity. It's their navigation service provider in Spain. But I want to highlight the relationship also that we have. We rely on the Ministry of Transport, but how is our relation also with the authority, safety agency in Spain, AESA, and the CIA, the Spanish CIA, the DGAC, because we brought together, together with the Ministry of Defense also, the National Action Plan for Deployment of U-Space. I think it's a good starting point to introduce these innovative services. And of course, we are participating in the working group 105. We are not directly involved in the working group 112, that is related to eVTOLs, but of course we work in eVTOL projects under CESAR framework. And especially we're working in the subgroup 3, that is related to UTM and U-Space. And what we are working, it's what it's called the interaction between the U-Space service provider and the U-Space regulation. According to the regulation, the AMCs, there is already a standard for interchange information in a distributed mode between different U-Space. But in Europe, some countries have the demand of having a more centralized exchange of information between different USPs, and that's the reason under EUROCAE framework is being developed under the ED339, that is under review, internal review, for the exchange information between USPs and also with authorized users in this context. We are also participating in the ULCOM project that is led by Eurocontrol, and it's a real example of how we're using a CESAR project for a real deployment of U-Space in Spain. It's participating, of course, also France and Italy. In Spain, there are 8 different communities involved. And the first U-Space volume that it's under airspace risk assessment evaluation will be Benidorm city, because a special landscape. It's a city that is high populated, close to the sea, good weather, non-controlled space. So I think it has good conditions for to be the first U-Space in Spain. Of course, we are participating how to integrate these eVTOLs operations in airspace close to airports, the dynamic reconfiguration for this kind of vehicles, new concept of operations, and ensures it's an example of the interaction between ATM and U-Space. And finally, participating also in EURECA projects and Opera that is more related to VTOL operations in controlled space and uncontrolled space. So I give the floor now to Daniel Molina for his introduction. Please.
Thank you very much. Good afternoon, everyone. It's a real pleasure to be here and to participate in this panel and to share Bluenest vision in this fascinating innovation sector, right, for air mobility. Well, my name is Daniel Molina. I'm currently the head of operations of Bluenest, which is a venture from Global Via, which is one of the world's leading transport infrastructure concessionaries. Well, as my background, basically, just a summary, I'm a telecommunication engineer with over 20 years of experience in technology projects, ATM, and airports. across many countries, Latin America, Africa, Middle East, Europe. So, well, talking about Bluenest, well, while many companies in this sector are focused on developing and making the aircrafts, the future eVTOLs and the drones fly, we are in Bluenest, we are mainly focused on landing them well and land them where they are needed most. So for that, our journey started in 2021. We were branded as OpenVia Air and rebranded to Bluenest in 2022, 1 year later, with a clear mission, which is to develop and operate vertiports and ground infrastructure that enable logistic, passenger transport, and automated drone services, UAS. And also to act as the enabler of ecosystem, providing the critical missing link between air and ground, and to ensure that the operations will be safe, reliable, interoperable, and of course, scalable. So this is the timeline of our journey, basically from our foundation in 2021. The highlights, we have participated in some research projects as EUROCAE, for integrating the vertiports in the multimodal mobility. Also welcome, participating together with ENAIRE, Daniel just mentioned, promoting these operations with drones for logistics and medical transportation. Also ALEHOP, which was another project for promoting the medical urgent transportation of goods. And other relevant milestones, we designed the first prototype of vertiport by 2022 for the World Cup at Doha in Qatar. That was the first operative, say, heliport. And in 2024, last year, we tested our vertical control system in Costa Rica with the first flight passenger eVTOL. It was an EHAM in Guanacaste. And basically that was our journey so far, and we are planning now the new flight campaigns. So this is these are some pictures of our some renders of our vertical control center. It's now it's integrated in the right side of the picture. You'll see that it's integrated in a van that we move for our flight campaigns for the different projects we are cooperating with. And finally, I'd like to say that obviously we don't manufacture vehicles. Instead, we build a nest where these vehicles will safely land, charge, operate, and connect. And it's very important that these nests are designed to be technology agnostic, to be able to interoperate with any eVTOL, obviously any equipment, any UTM provider or operator, and to be aligned with the multimodal integration principles. Also, we have designed a lot of concepts of vertiports, future vertiports, as for rooftop, urban areas, coastal areas, logistic hub, healthcare facilities, so far. And the most important thing is that beyond infrastructure, our real focus is on people and purpose. So our ambition is to place the citizen at the center, ensuring that these vertiports will become the new mobility hubs, connecting communities, improving the accessibility, and reducing the congestion. So it's our mission, basically, just to conclude here our presentation, is to accelerate the integration of the IAM into real life, because of course, without the ground infrastructure, this potential industry that is going to be it's coming soon. Will remain as potential. That's obviously, it cannot be like that, because IAM is not only about flying, but also is about landing well. And from Bluenest, we are building that landing ground. That's all.
Okay, thank you very much. Fabien?
Thank you. Okay, so I will introduce you CRISALION. So CRISALION was created in 2019. Formerly, the company was called UMiles Next, UMiles. At the beginning of the story of the company, it was dedicated to drone leisure, drone shows, and our founder, Carlos Poveda, thought one day, okay, we are having fun with our drones, why don't we try to transport people? And this is where emerged the idea of CRISALION, okay? So you can see here, we have two types of products. We are dedicated to air mobility, okay? I will talk a little bit later on about our Integrity eVTOL, which we are developing right now. But maybe it is less known, but we also have urban ground mobility, which is based on a patent we have developed to be able to drive remotely vehicles, okay? So we have one philosophy, one strategy, that will be to introduce eVTOL into service with pilot, but we also develop in parallel the capacity of driving a vehicle remotely through our ground field, so that in the future, maybe we could remotely also drive eVTOLs. Okay, so that's a little bit the philosophy of the company. Well, why are we there? Mainly, we want to address one, I would say, common issue. We all know about difficulty to commute on a daily condition, to go to work, etc. I would say that's part of the picture. We don't want only to try to find a solution to this, but we also want to make adequate communication between isolated places, for instance, through medevac also missions. We want to provide also leisures, some kind of mobility that could be useful for visiting places that are known by people. So our concept of operation is not only related to urban mobility. There are a lot of many and possible applications for eVTOLs that you might already know. And I will maybe come back again on that point, because I think that in terms of public acceptance, maybe this application is not the first one we should focus on. But let's come back to this point later on, okay? So as I said, here today we are here to discuss a little bit about air mobility, urban air mobility. I will also discuss a little bit more later on this point, but we started our history in 2019 working with Tecnalia. So Tecnalia is located in Basque region in Spain. It's a research center, and we developed jointly a patent that we called Fly-Free, which is basically how the 16 motors we use are mechanically coupled and how they behave to be able to provide a stable eVTOL and also a safe, for sure, eVTOL. So this was one of the first prototypes we used some 4 or 5 years ago. It's still flying, and that we are using as a base to develop the current architecture. So after several years of experimentation, flight hours accumulated, we came to the final architecture of our eVTOL, and this is what we are working right now, okay? So we still are at the preliminary phase of the formal process, okay? We have defined a full CONOPS, what we want to do with our aircraft, how we want to operate it, and what will be, I would say, the basic engineering Legos we want to use to be able to provide this final product. Okay, so you can see here the characteristics, main characteristic of our Integrity eVTOL. I would say we want to use conventional technology. We don't plan to be a revolution in terms of technology use. We want to use consolidated technologies to be able to provide the mission profile we are proposing. So this is a mix of, I would say, implementation of new regulations, but based on existing technology, okay? So later on, I will come back a little bit to our concept philosophy. We have developed prototypes, what we have in mind behind, what is our strategy, and how we want to manage risk also in terms of project management. Thank you.
Thank you, Fabien. Now, Javier.
Thank you. Hello, good afternoon, everybody. Thank you to EUROCAE for organizing this symposium in the beautiful city of Madrid. Thank you also to Bertrand for organizing this panel. Thank you to my fellow panelists. It's a real honor to be part of this discussion. I hope this is not only because we are sponsors, but yeah. Well, my name is Javier Romillo, and I'm a senior safety engineer at Anzen Engineering. And today I would like you to share a little bit more about who am I and what do we do at Anzen, especially our role in developing mission-critical and safety-critical systems. So I hold the master in aircraft system integration by Airbus, and that's where I started my career, thanks to Isabel, who is here today. There I participated mainly on medium and light projects, such as the certification of the Canadian fixed-wing search and rescue aircraft. Then I moved to Skydweller, which is a really challenging and sustainable project, aiming for perpetual flight based on solar powered. There we develop an in-house fly-by-wire, which is something to be proud of. And since the last 3 years, I've been working at Anzen, supporting the first passenger-carrying autonomous VTOL to be certified by the FAA. I'm also a member of some EUROCAE groups related to safety, hydrogen, hybrid propulsion, and VTOL. So moving on to Anzen, we are, well, for the ones that don't speak Japanese, Anzen means safety in Japanese, very original, right? We are a team of already 60 highly specialized engineers. We have the headquarters in Madrid, but we also have an office in Lucerne, in Switzerland, and a small engineering team in the States. We define ourselves as an agile and flexible global company. So here you will see some of the examples of the platforms we participate in. You will see some of the most relevant ones, from traditional aviation to UAS, defense, but also some really innovative ones as the flying taxis. It's worth to mention that we don't work only for OEMs, but also for system and equipment suppliers. So this is a little bit of a summary of the growth so far and the forecasted growth for the company. The company was founded in 2019. So you can see the growth has been pretty exponential. And our expectation is to triple the size by 2028 compared with the numbers in 2024. That's a reflection of the market trend, but also a reflection of the trust from our partners. Regarding innovation, it has been one of our pillars since day one. We have been involved in several projects related with system of system, model-based system engineering, model-based safety analysis, and we even have developed our own safety software for classical and model-based safety analysis. Probably one of the best examples of this commitment with innovation is our participation as a strategic partner in the Aston project led by Boeing, where we try to harmonize a little bit the supply chain in terms of safety and reliability with model-based methodologies. And last, I would like to wrap up a little bit with a little summary of what we do. And taking advantage of the name of this panel, I think we can support you from the concept to the implementation, including requirement definition, validation, verification, architecture trade-off. And yeah, if you have a complex, critical, and ambitious system, that's where we thrive. So thank you very much, and I would be happy to discuss further after the panel with whoever it wants. Thank you.
Thank you, Javier. So we talk about vertiports, about eVTOLs, and now it's time to drone delivery with Diego.
Yeah, hello. So my name is Diego. I deal with regulatory affairs at Wing. And for those of you who don't know Wing, it's a drone delivery company, a subsidiary of Alphabet. That means Google's parent company. That was founded in 2012 with the objective of leading the way in drone delivery in both urban and suburban areas. And actually, the picture that you can see on the right is from our ongoing operations taking place right now as we speak in central London between two hospitals of the National Health System of the UK. So what we have done so far since 2012 is basically to develop and launch a highly automated and contactless drone delivery service. With the support of our global partners like DoorDash, Walmart, and also NHS and Aviation in the UK, we have completed over 450,000 flights across 3 continents, meaning the US, Australia and Europe, of course. And just as a fun fact, our delivery personal record is of just 2 minutes and 47 seconds. So if we have a closer look at the aircraft we designed, as you can imagine, it is an aircraft, a drone that is specifically designed for airborne drone delivery of small packages. So basically, it's an aircraft of 1.5 meters of wingspan. It weighs about 5 kilograms, a little bit more, and can carry a payload of around 1 kilogram. The maximum range is 10 kilometers, more or less, and the cruising speed ranges between 90 and 100 kilometers per hour. The aircraft features multiple levels of redundancy, explaining therefore the number of hover and forward flight rotors, and high levels of automation, as I was saying before, allowing the aircraft to handle all tasks associated with a mission. And then finally, I want to give you a flavor of how our operations look like today. So basically, the drone delivery operations are conducted beyond the visual line of sight of the remote pilot, BVLOS, and at very low level, meaning below 120 meters above the ground level. So of course, everything starts with an order. So as soon as we receive a delivery request, the mission is automatically assigned to an available aircraft. And our flight planning system automatically computes a safe 4D flight route that takes into account the aircraft performance, the operational volume, and the surface profile, and is deconflicted from airspace restrictions, known obstacles, and other known aircraft, including other wing aircraft. So the drone, after doing some pre-flight checks to verify the health of its systems and warm batteries, will take off and fly to the to the pickup location, where it will hover at around 7 meters above the ground, where it will lower a tether, and the package will be attached to a specialized hook. Once the package is attached and secured for flight, it will climb to the cruising altitude, which is normally between 30 to 40 meters above overflown obstacles, and will transition into forward flight. Then, upon reaching the delivery location, it will slow down, will descend, and lower the package and release it upon making ground contact. Then, once the delivery is completed, the aircraft will again automatically go back to the launch facility, where it will land and recharge batteries on a landing pad, while other aircraft complete other missions, other deliveries. So basically, the closing remark for this is that we are not talking about far off future technology, but something that is already taking place today. Thank you.
Okay. Thank you, Diego. Okay, so let's tackle what we call the segment 1, that it's concept, prototypes, regulations inside innovative aerial services. So let's start with Daniel. According to your introduction, within this, your mobility concept, what is Bluenest most interested in and why?
Well, what interests us most basically is how to make this whole ecosystem operational, taking into account the regulation and the infrastructure to be two sides of the same coin. If we look back to the history of the aviation, the lesson is clear that with the aircraft alone, the business is not possible. It has to be integrated with all the ecosystem that is built in, such as the airport, the air traffic, the procedures, and basically all the stakeholders involved. So this new concept, AAM, is facing new challenges and new complexities, different. Some are the same, some are different. Basically, the ground, it will be closer to the ground infrastructure, will be closer to people, and will have a broader ecosystem, taking into account not only the airlines, airports, but also, for example, the OEM, eVTOL manufacturers, energy companies, municipalities, logistic operators, and last but not least, the expectation from society in terms of noise reduction, in terms of safety, which is quite important, in terms of making their lives better, right? So, from Bluenest perspective, we are very interested to see how evolve this passive infrastructure to digital active nodes, integrating in the airspace, UTM providers, basically all the integrating in the logistic hubs, and basically in the infrastructure, in the ground infrastructure, and also to be part of the new air mobility networks and provide these digital nodes, provide predictability, efficiency, and very important, the safety. So it's quite important. There is a message that is quite important, is that the regulation and innovation must be aligned, right? Together with all stakeholders that are involved. That's why we are really engaged with research projects that we are participating together as Welcome or EUROCAE, where we can validate not only the technology, but also the procedures, the interfaces, the operation, and to validate the safety under controlled scenarios, right? That is quite important.
Okay.
So we believe in this kind of development in different phases, just to build, to construct the trust for people, which is very important, because this industry, this business, will not be a reality without that trust from the citizens. So there will not be business. It's as much as critical the technical readiness as much as this trust, right? So basically, we are convinced that the infrastructure will define the experience and will scalable the IAM. As a gap, as a data, there's research saying that there's billions of investment in the eVTOLs, in the equipment, but it's around 50 times less for the infrastructures. And from Bluenest, for the infrastructure companies that will be providing, it's quite important to close little by little that gap. Mm-hmm. And just to finalize, says that this conversation is not about saying these vehicles goes first and infrastructure later. That has to be everything aligned, just to be able to allow this IAM become a reality.
Okay, clear, very complete. And now with the client, with the eVTOL that is going to operate in vertiports. Fabien, you are part of a project, as you have presented, very important, related to eVTOLs, a part of course, the ground vehicle, the autonomous ground vehicle. What can you tell us about this?
So maybe I will introduce a little bit our philosophy, development philosophy. I would say, at the contrary of some other big companies like Airbus, Boeing, we cannot base our new developments on previous experience. We are starting from scratch. That's a reality. We need to be very humble and say, okay, how can we start an engineering phase with only an idea, a motivation? So, as I said, we started in that case believing that our fly-free technology could be, I would say, a new technology motivating this product, and we started using the knowledge of Tecnalia to develop this first concept. This first concept, as we have seen before, that we also familiarly call the egg, el huevo, has been the first platform we used to be able to validate our technology, mechanism, propulsion system, flight control laws, flight control system, and to take knowledge from this, and then from a purely engineering perspective say, okay, this is the architecture I want to develop, and this is how I will start now my formal development and certification process. We still need to converge on a stable architecture. Right now, we know what kind of product we want to develop. This is what I was showing to you just before. But I would say that prototypes are key here, not only to demonstrate that we are doing beautiful things, but to be able, before starting a formal certification process that you might know is much less flexible in terms of design changes, to be able to get this, capitalize this engineering knowledge, develop a basis for requirements, condition of operations, safety conditions, etc., and to get this basis to start a new product. Okay, we cannot be burning budget infinitively. We have some limitations, we know it, we also seen the experience from other competitors, and that's why we believe, from CRISALION point of view at least, that we still need to progress on prototypes before starting this formal process, and also increasing in terms of organization, okay? So we have done one concept some 2-3 years ago. We started progressively with inside internal doors, conditions without gust, control conditions. Then we flew outside with gust and other condition of operation. And now that we have a fixed architecture, we will do it progressively also, using, again, prototypes. Small scale, 1 to 6, just to see if our flight control laws are still adaptable to this new concept. And we'll use also, in 2-3 years, we hope to be able to fly a 1-to-1 concept, okay, by piloting it remotely, definitely, there is no pilot, so that we can freeze this configuration to start formally the certification process. So that's why I say concept plus prototypes are a key element to start the certification.
Okay, thank you. Javier, same question. This part of the concept of operation, prototypes?
Yeah, absolutely. Totally agree with what Fabien already said. We need to start thinking of prototypes as strategic development tools instead of just technical milestones. I've had different experience with my former companies. In one of them, we had just one prototype, so we had to pay special attention to be very careful. We could not lose that prototype. But in the other, we had like 6 different generations of prototypes with several instances of them, which makes you the process much faster, and the growth could be exponentially, because you can be testing and running different flight test campaigns in parallel. So at the end, the prototypes are the only way to learn by iteration instead of by assumptions. They are the only way to close the gap between simulation and reality. And if, for example, we take a look at SpaceX, we can realize that having an almost continuous stream of prototypes is what is making them fail fast, learn faster, and ultimately succeed. So absolutely, prototypes are key, and the more you spend on them, the more risk you burn, and the more growth you can have.
Okay. Okay, changing to Diego. You mentioned in your presentation a high level of automation in the operations. Are the current regulatory tools sufficient to support greater automation and scalability of US operations?
Yeah, so essentially based on our experience with SORA-based authorizations in both Europe and Australia, we believe that the current regulatory tools generally translate well to highly automated BVLOS operations with one pilot to many aircraft ratio. But of course, we recognize as well that the industry could benefit from certain regulatory, targeted regulatory updates for further development and scalability. One of the examples, for instance, is, as I was mentioning before, there are certain tasks, certain duties that are currently falling under the remit of the remote pilot in command. And we believe that these will need to be eventually shifted from that pilot to the operator. For instance, the mission planning and assignment in our case is not performed by a person. It's performed by our systems, our drone delivery systems. The same applies to the pre-flight checks. They are not performed by the pilot or a technician. They are performed by the aircraft itself to verify the health of the systems and the warm batteries prior to a delivery mission. So in other words, we believe that as the technology in drone operations advances towards greater automation, having a human in the loop may become unnecessary and in some cases even adversely impact safety. So that's why we believe the emphasis should be placed on the operator's safety management system and processes rather than on the individual role definition.
Okay, perfect. So moving now to the segment 2, to the implementation and operations in the panel. Daniel, tell us a little bit about practical and real solutions that we may see soon with the use of vertiports.
Yes, well, first message I'd like to share, which is something optimistic, is that the IAM is not something that will happen in 2035, 2040. It's something that is happening already. So we are seeing now practical applications and tangible that, for example, that are happening right now, for example, for the delivery of medical deliveries, cargo application as well, where the vertiport can give a real value. And this infrastructure will be relatively simple and with also can be run with flight corridors regulated. So they will provide obviously ground saving times, obviously money savings, and which is really practical. Also, we have, for example, I can share that we are promoting flight campaigns. For example, now we are working on a project for the Canary Island together with the government of Gomera Island, Cabildo, to a campaign which will happen next May for a pilot, a pre-operational concept for transport of medicaments. So, and also we have another flight campaign that will happen under the framework of the Welcome project with a special flight corridor to transport also medicaments from the hospital La Paz in Madrid and Carlos III, That is something that is quite interesting, that is, I think, can be applied and will, of course, make the life better for people. And other use cases, the cargo applications for remote areas, offshore platforms on the coast, also anchor ships, and of course thinking about real cases that can be covered for rural areas or remote location where the geography is very challenging. So that's quite interesting, and the thing is happening now. We are not far away. The contrary is happening now, and we have that system that can give a good value. And in a future phase, obviously, we have to think of the passenger transport. And first thing, we are convinced that will happen in coastal areas for communicating where you have the intercity coastal areas where you can save important time considering the traditional transport methods. And a later phase for specific connections in urban areas from airports, for example, so this to city centers or to business districts where will be premium, obviously, and there is a congestion, and you can save considerable time just to take this opportunity. Right, so these are basically those use cases that we see in short term, and I have to remark again that all the ecosystem have to work together: the UTM, obviously the eVTOLs, the infrastructure, the safety procedure, the regulation, everything have to work together. We have to think first. Making not the perfect system, but to start with something to validate the user cases, to validate the operation, and remark the social acceptance to make this a reality.
Okay. Fabien and Javier, what can you tell us about the safety challenges in this innovative air mobility concept? You will talk about prototypes and go to real operation and the million-dollar question, right? When we'll see this?
Okay, maybe I will start, and Javier, you can complete based on your experience and knowledge. So I would say that for eVTOLs, we have one big constraint, finally, which is we still have an evolving certification standard context, and we need to freeze type certification and develop one aircraft. So how to manage the design development with a legal framework that potentially is evolving a lot. We have seen some of our competitors, like Volocopter, had strong difficulties because they developed one concept of operations that finally was not certificable. So they had to start again, which induces a lot of cost, time, etc. So we have this constraint. Another constraint we have, difficulty. Compared to Airbus, Boeing, we cannot base our knowledge on accumulated flight hours in service. We cannot say this system is safe because I already operated it before and I know it works. So we need to be much more cautious, maybe against weight, or we have to take other decisions. So that would be, I would say, the two ideas. And finally, I will also add that that's not only safety, but also security is an important word, because eVTOLs are called to be really connected elements. As if we want to operate in urban conditions, we'll have to be connected through 5G, GNSS, very accurate position systems, and how can we integrate this against the new cybersecurity requirements, and how to make this aspect really strong in case of attacks, whatever. So that's another point we need to really concentrate on. We already know that with ED 202, 3, and 4 that have been created, we need to start developing based on the standards, but that's new, and we also need to learn and implement it. So I will let Javier.
But you didn't answer when.
You are really curious. So I would say that we are being very cautious on CRISALION side. I talk from my company. I don't think we'll be able to have something by 2030, 32. We don't want to be the first one, for sure, to operate. We want the other ones to experiment, and being the second wave, let's say.
The reason is because we're running out of time, and maybe it was a question that maybe something from the audience, and I advanced it, so Javier.
Yeah, I'll try to be fast, and to build up a little bit on what Fabien already said. I will focus a little bit on more technical safety challenge. So far, I would point out 3 of them. The first one is the energy storage and management of eVTOLs, either lithium batteries with the thermal runaway or hydrogen-powered eVTOLs with leakage and high-pressure problems. It's one of the key aspects to take care of. Also, the common mode analysis, which is it's pointed out in the ED300A by EUROCAE, which is under review these days. We have several instances of the same items for the distributed propulsion and actuation systems. So there is a latent risk for commonalities to really impact the safety of the aircraft. And other thing which is kind of new in the safety world is the cascading effect analysis. There are 2 flavors of that in the eVTOLs, because we have a lot of critical functions in a really compact space. But also we have plenty of propellers spinning, so an initiating event like a propeller brake release or an overheating in a system can affect cross systems, and that's something to really pay attention. Sometimes the most difficult thing is not that we are not challenged to design a safe aircraft, but also to define what is safe in this context. And answering the second question, I will be a little bit more optimistic than Fabien. There are some key players in the States that are aiming for starting operation in around 20 months, probably restricted, not full operations. But it's also true that this is for piloted aircraft. If we talk about autonomous aircraft, I don't believe we will be having operations before the end of the decade or beginning the next one.
Yeah. Okay. Well, we are running out of time, but very briefly, Diego, could you share with us more information about what you mentioned about simultaneous drone operation? I think it's quite an important concept, and the role of automation in the operations.
Yeah, so, well, as I mentioned before, automation plays a key role in every single component of the wing delivery system, allowing for significant reduction of the human intervention. So the wing pilot oversees multiple aircraft operating in a given area, and they do it from a remote location, which might be miles away from the actual operation. So for instance, in Australia, we have a 1 to 50 pilot to aircraft approval. And this is possible because the duties of our pilots involve only those areas which have not yet been automated, completely automated yet. This is, for instance, the monitoring of the surrounding occupied air traffic, the monitoring of the weather conditions, the communication with air traffic control or law enforcement authorities as needed, or the adherence to dynamic flight restrictions. And also to note that our pilot cannot manually take control of the aircraft. They just have 2 commands available for safety purposes. So first one is pausing operations, meaning that airborne aircraft will continue their missions until completion, while other missions will not take off. So, as you can imagine, based on the length and the duration of our missions, in the worst case scenario, in around 4 to 6 minutes, all our aircraft will be grounded. And the second command for, let's say, more pressing scenarios is a land now, which basically is to initiate an immediate contingency landing that can be applied to one, several, or all aircraft in a given area.
Okay. Thank you. So I think we have 5 minutes, right, or 4 now. So maybe we have time for some questions from the audience. So you tell me. Okay. I think this is for Diego. Do you foresee a maximum number of delivery and people transportation operations? How do you ensure full interoperability among all players?
Can you repeat the question?
Yes, foresee a maximum number of delivery and people transportation operations. Maybe if there is some study of density or maximum density of operations, maybe in the same area, or do you have some experience in that, or interoperability among all players? Maybe.
Yeah, so if I understood the question correctly, so we operate in, for instance, we have very intense drone delivery operations in the Dallas area in Texas. That is a suburban area where, let's say, we cover a relatively vast area, and where we have partnered with Walmart, as I said at the beginning. And we don't foresee any limit on the maximum of deliveries that we receive. Of course, we are building step by step on, let's say, the one-to-many aircraft approvals in the US, in Europe, and Australia. But yeah, we don't see any limit in that.
Okay. They erased the questions, but I remember the question I was going to ask, and was to both of you. And it's related, it's a tricky question. Regarding to the problems, economic problems that other companies that we know related to eVTOLs have in place, how do you change how you are addressing the challenge of these challenge of the implementation of this concept of eVTOLs?
In the case of CRISALION, I would say we are being really conservative on the way we consider the technology we will use. So we want to base our product on known technology. What does it mean? That known technology is known efficiency, known reliability, and known cost. So that when we have investors coming to us, we can say, okay, this is this amount of money, this time, because we know the processes, we know the product. We don't want to invent nothing. The only new we are proposing, I would say, the added value we are proposing is our flight-free technology, which would make the aircraft a bit more stable and a bit more comfortable somehow. Mm-hmm. This is the only difference we provide. So, as I said, the second point, philosophy we are considering is not to be the first one. The first one, I think, is suffering hiccup into legislation aspects. Starting operational service is not easy. You discover a lot of difficulties. So associated costs, risk also. And that's why we want to be observing the ecosystem and reacting during our design process so that we have time to implement changes, if necessary, at a lower cost.
Okay, understood.
Yeah, from my side, I would say that there is, I believe, a big difference between what is happening in the US and what is happening in Europe. I see a lot of more support, economical support, governmental support in the US, with a lot of key players already pretty advanced in their developments. But to be honest, everybody knows in this industry that there will be some kind of consolidation of the competitors at some point. So I think that's why everybody is trying to progress as much as possible to get to that point in the best possible position.
Okay. Okay, so this is the end of the panel. Thank you very much. Thank you very much for the speaker. I think it's quite interesting, addressing different topics and different perspectives. So please welcome them, and thank you very much. Thank you. Okay, thank you so much.
All right, perfect. So thank you to all our previous speakers. Very interesting to see how different companies address those challenges of bringing innovative services to life. We saw one part of this innovative aerial ecosystem. Now I propose to address the regulator point of view, and specifically ICAO role. As you may know, unmanned aircraft system, remote piloted aircraft system, advanced aerial mobility, and electronic vertical takeoff and landing system fall under the Chicago Convention. ICAO enforces global aviation governance by ensuring safety, security, and standardization across national airspace. In the following video, Michele Merkle, Director of the ICAO Air Navigation Bureau, will help us understand how the principle of the Chicago Convention apply to UAS, AirPass, AAM, and eVTOL. Then, Frédéric Malaud, Chief of the ICAO Remotely Piloted Aircraft Systems section, will explain how ICAO plays a vital role in facilitating the safe and efficient integration of AAM into global airspace. I wish you all a very pleasant presentation. Thank you.
Aviation is about more than moving passengers and cargo. Every journey must be reliable, accessible, and seamless. ICAO provides a global forum for member state collaboration to ensure technical standards, procedures, and guidance make this vision a reality. By harmonizing air transport facilitation and advancing aircraft and aerodrome operations and air traffic management, ICAO ensures the delivery of seamless global mobility for all. Flights have to be on time and efficient. ICAO brings aviation experts together to improve the regulatory framework for aircraft and aerodrome operations and air traffic management. This includes developing global standards for communications, navigation, and surveillance systems, and improvements to aeronautical information and meteorological services. These efforts support the growing range of aviation activities, from commercial flights to advanced air mobility and unmanned aircraft systems. Reliable air navigation is key to the smooth operation of air traffic. ICAO works with member states to maintain and improve air navigation services, develop global, regional, and national air navigation plans, and protect critical communication and navigation systems against emerging threats. Through this work, the integrity and resilience of the global air traffic management network is safeguarded. Achieving seamless mobility requires a coordinated effort. ICAO works with all regions to develop and update regional air navigation plans that address local and global challenges. ICAO's aim is to ensure all 7 ICAO regions implement fully coordinated plans that support safe and efficient air navigation worldwide. As global collaboration grows, the aviation sector must embrace innovation and sustainability to meet evolving demands. ICAO supports the integration of new aviation technologies, enabling transformative services and modes of mobility. These advancements rely on innovative aircraft, propulsion systems, digitization, and increased automation. From advanced air mobility to unmanned aircraft and remotely piloted aircraft systems, ICAO is shaping the future of aviation by developing regulatory frameworks and ensuring their safe integration in the global airspace.
It's my great pleasure to join you on behalf of ICAO for this year's annual symposium of EUROCAE. EUROCAE is one of the leading standards development organizations, has contributed greatly to the growth of aviation. With its technical expertise and resources, EUROCAE has an essential role, which is very complementary to ICAO's activities. The safe, secure, efficient, and environmentally sustainable development of aviation depends on aircraft and associated equipment being designed, manufactured, installed, and maintained to high standards. This applies to conventional aviation as well as to new entrants. Let me start by highlighting that UAS, AAM, RPAS, and eVTOL are aviation operations under the Chicago Convention. The Chicago Convention on International Civil Aviation established the foundation for global aviation governance, ensuring safety, security, and standardization across national airspaces. While originally drafted with conventional aircraft in mind, the principles of the convention apply to UAS, AAM, RPAS, and eVTOL operations as well. Firstly, UAS and RPAS that operate internationally fall under the scope of the Chicago Convention and must comply with ICAO's safety and regulatory requirements. Article 8 of the Convention states that no aircraft capable of being flown without a pilot shall be allowed to fly over the territory of a contracting state without special authorization. This provision directly applies to RPAS and UAS requiring regulatory coordination at the international level. Secondly, as aviation operations, UAS, AAM, and RPAS must be safely integrated into controlled and uncontrolled airspace. This requires adherence to ICAO's standards and recommended practices, including requirements for remote pilot licensing, detect and avoid systems, and air traffic management integration. Thirdly, the growth of these technologies necessitates consistent regulatory frameworks across jurisdictions. The Chicago Convention provides the necessary legal foundation to ensure that UAS, AAM, and RPAS operate under harmonized regulations, preventing fragmentation and conflicting national policies. Firstly, market growth and investment. The global market for UAS and AAM is expanding rapidly, attracting investment from both the public and private sectors. According to some industry forecasts, the UAS market alone is expected to exceed hundreds of billions of dollars in the coming decades, driven by applications in logistics, infrastructure, and mobility services. Secondly, job creation and workforce development. The emergence of these technologies is generating new employment opportunities in manufacturing, operations, software development, and indeed, governance and regulatory oversight. As AAM systems become commercially viable, industries will require skilled personnel, including remote pilots, maintenance technicians, and air traffic managers specializing in UAS and eVTOL operations. And thirdly, cost savings and economic efficiency. By reducing fuel consumption, maintenance costs, and infrastructure requirements, unmanned aircraft and AAM technologies contribute to more cost-effective operations. Airlines, logistics companies, and emergency service benefit from lower operational costs while improving service delivery.
As the international body responsible for civil aviation regulation, ICAO plays a vital role in facilitating the safe and efficient integration of UAS, AAM, and RPAS into global airspace. This cooperation is essential to ensuring uniformity, safety, and economic viability. The first priority for our organization, in keeping with the mandate to support international air navigation, is the development of RPAS standards and recommended practices. This work applies specifically to the certified category of international unmanned operations, which is an important component of the overall evolution that will lead us to advanced air mobility. In addition to the work already completed for remote pilot licensing, the C2 link, and airworthiness, ICAO is also now finalizing standards for RPAS operations, air traffic management, detect and avoid, and aerodrome operations. Many more RPAS provisions will be forthcoming during the next few years, and this progress will also feed into the AAM ecosystem. However, there will need to be parallel tracks for many new types of aircraft and operations. The second priority for ICAO in this area is to help national authorities and industry design, develop, and implement fit-for-purpose regulations for UAS operations, which fall outside of the scope of current international instrument flight rules. We have provided states with model UAS regulations and courses, specific guidance material for humanitarian operations, and ICAO's UAS traffic management framework, as well as tailored guidance material packages to help countries establish their national regulations for smaller UAS. The third priority is the development of AAM. AAM is described in ICAO as a set of aviation activities involving the transport of people, goods, as well as other use cases such as data collection, agriculture, infrastructure inspections in urban, regional, rural, or remote areas using advanced or innovative aviation capabilities.
The rise of UAS, AAM, RPAS, and eVTOL aircraft represents a transformative shift in aviation, offering substantial operational and economic benefits across various industries. However, their successful integration into global airspace depends on adherence to international aviation regulations established under the Chicago Convention. ICAO is looking forward to playing its role together with EUROCAE in ensuring harmonized regulatory frameworks, promoting safety, and facilitating international cooperation. Recognizing that many of the technologies and capabilities being realized through AAM research and development will lead to crossover benefits in conventional aviation, and that integration with traditional operations poses both known and unforeseen risks, ICAO, as well as EUROCAE, will need to maintain a clear and vigilant focus on ensuring the safety, security, and environmental sustainability of all operations. Given our two organizations' roles in helping states and industry to work together connecting our world, let me please conclude today by noting how appreciative we are of the 60 years of constant efforts of EUROCAE to support the aviation industry, and how much we look forward to working collaboratively for many years to come. Thank you.
And I think we can just return that thanks back to Michele and Frédéric and all the other colleagues in ICAO for a very, very robust and good collaboration that we have with them, whether this is on the RPAS side with the RPAS panel and the AAM study group, or the many other activities that we're working together with ICAO. So thank you very much for that, Michele and Frédéric, taking the time to join us today, even if remotely. With that, I'd like to invite you to our next agenda item, which is the lunch break. You see we're getting onto Spanish time, almost. It's getting a little bit later than usual. But please enjoy and be back promptly at 14:30 for our final session of the symposium. Bon appétit.